In this video, we'll see how the supply voltages affect the output currents of the op-amp. Consider an inverting amplifier. Suppose we have an input Vn. We will get an output equal to minus R2 by R1 into Vn. Assuming the op-amp is ideal, there is no current through the inputs of the op-amp. However, the current at the output through R2 and R1 is minus Vn by R1. Hence, if we look at this entire amplifier as a black box, then it seems to violate Kirchoff's current law. There is no input current, but we still get an output current. How can that be possible? In our analysis so far, we have not included one of the most important aspects of the op-amp, the supply voltages. It can also be drawn like this. This output current is provided by the supply voltages. It may seem a bit weird, but the model for this is quite simple. The current through the input terminals is 0. Let the current at the output be I out. We'll call the current through positive and negative supply voltages I plus and I minus respectively. If I out is greater than 0, then I plus is equal to some value I naught plus I out. In this case, I minus is I naught. Let's verify KCL for the op-amp. I minus and I out are leaving the op-amp and their sum is equal to I naught plus I out. I plus is entering the op-amp and is equal to I naught plus I out. Hence, the current leaving the op-amp is equal to the current entering the op-amp. Therefore, KCL is completely valid. If I out is less than 0, then I plus is equal to some current I naught. I minus is equal to some current I naught minus I out. In this case, KCL is valid too, which can be verified with a similar analysis. For example, if we have a sinusoidal input to our inverting amplifier, we will have an amplified inverted sine wave at the output. Current will also have a similar waveform. During the positive half cycle, I plus will follow I out with a DC shift upwards of some value I naught. During this time, I minus will be constant at I naught. During the negative half cycle, the exact opposite happens and this continues. Note the directions of I plus and I minus. Thus we see that KCL is completely valid for an op-amp, which makes sense because KCL is based on the fundamental concept of conservation of charge and hence cannot be violated. That's all for this video. If you have any doubts, please ask in the comments section below. Don't forget to like, share and subscribe.